Dear student, this class I am going to discuss about organic chemistry, some basic principles and hydrocarbons. First of all, you know that here in case of the organic chemistry, some basic principle you studied how to name the organic compound like a IUPAC nomenclature. It is one of the very important concept in IUPAC nomenclature. During the IUPAC nomenclature of the any compound, you must know the certain rules like that. You have to find out the which one is the root word. What is the meaning of the root word? The total number of the carbon atom in a linear chain. Okay, the total number means in a linear chain how many number of the carbon atom is there, that is called as a root word. Then the whatever the carbon atom you are not given the number, that is called as a substituent. Okay, I will move on to the first question on the basis of the IUPAC nomenclature. The question is like this: the correct IUPAC name of the following alkane is. Here you have to go for the number for the carbon atom. Here I will proceed the number of the carbon atom. Whenever I can be proceeds from here, the first, second, third carbon having the substituent. Okay, here the third carbon having the substituent. But whenever I can be proceed from here, first, second, then third carbon having the substituent. Okay, the substituent must get the least number. Therefore, I will proceed to here. Therefore, this is the carbon number 1. This is the carbon number 2. Here, the carbon number 2 having the substituent like a CH3 group. Then this is the third carbon, fourth carbon, then fifth one. Okay, fifth one here, fifth one, then sixth one, then seventh one and eighth one. Therefore, the total number of the carbon atom in a linear chain is 8. Therefore, root word is octane. Root word is octane. There is no problem in the root word. The root word is octane. Root word is octane. The next, the second like a CH3. Okay, therefore, second carbon having the substituent like a CH3, it can be named as a methyl. Methyl substituent. Methyl substituent. Then third and the whatever the carbon atom you are not given the number. This one is not given the number. This CH2, CH3. Here also CH2, CH3. You are not given the number. Therefore, it must be taken as a substituent. 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 The substituent are present in carbon number 3 and carbon number 6 is ethyl. Carbon number 3 and carbon number 6 is a ethyl. There are two ethyl group is there. Therefore, 3,6-diethyl. 3,6-diethyl. Then second carbon having the substituent like a CH3. CH3. Therefore, it is a 2-methyl. 3,6-diethyl. 2-methyl. Then root word is the total number of the carbon atom is 8. Therefore, octane. Octane. Therefore, correct IUPAC name of this hydrocarbon is 3,6-diethyl 2-methyl octane. And hence, the option number A is the correct. 3,6-diethyl 2-methyl octane. Here there is no confusion, or in some cases there is some confusion like 2-methyl 3,6-diethyl octane they are given means you have to write the correct option is 3,6-diethyl because in the alphabetical order the E is coming first, after that M. Therefore, the ethyl is coming first in IUPAC nomenclature, after that the methyl. The correct answer is 3,6-diethyl 2-methyl octane. The next, we will move on to the next question. Which of the following reaction can be used to prepare methane? We know the structure of the methane, that is CH4. The first answer is Clemmensen reduction. Do you know that? What is the Clemmensen reduction? The any carbonyl group is there like a aldehyde or ketone. It can be react with zinc mercury with concentrated HCl. You are getting the corresponding hydrocarbon. Then Wood's reaction. In Wood's reaction, alkyl halide react with the sodium in dry ether. You are getting the higher alkane. Reduction of the CH2 double bond CH2 by lithium aluminum hydride. It can be undergo the reduction. Like you are getting the ethane is the product. Reduction of the methyl iodide by using a zinc copper couple. Actually here in this case also you are getting the same type of the hydrocarbon. That is a higher homologous of the hydrocarbon. It is somewhat same as that of the Wood's reaction. Okay. In this, the option, we will move on to the option number A. I will take the carbonyl compound HC double bond OH. It react with zinc mercury with the concentrated HCl. That is a in Clemmensen reduction. Clemmensen reduction. Now you are getting the product is HCH2 H. That is nothing but CH4. Okay. Therefore, the correct answer is which of the following reaction can be used to prepare methane? That is a Clemmensen reduction. Option number A is the correct answer. The next, we will move on to the next question. Question number 3. Arrange the halogens like a fluorine, chlorine, bromine, iodine in order of their increasing reactivity with alkanes. Here the option they are given. The one is fluorine, chlorine, bromine, and iodine. We know that as we move down the group, the electronegativity decreases. You have to answer these questions on the basis of their electronegativity. As the electronegativity decreases, the reactivity of the halogens also decreases. Therefore, in this case, the fluorine is more reactive for the alkanes, the next chlorine, the next bromine, then next iodine. Therefore, the option number A is the correct one. That is, iodine is less, then bromine, then chlorine, then next fluorine. The correct answer is this one: iodine, bromine, chlorine, and fluorine. Okay, this question you have to answer on the basis of their electronegativity. As the electronegativity decreases down the group like a fluorine, chlorine, bromine, iodine, on that basis their reactivity also decreases. Here in this case, the fluorine having the highest reactivity compared to that of the chlorine, then bromine, then iodine. The next, we will move on to the next question. Question number 4. The increasing order of reduction of the alkyl halides with zinc and dilute HCl is the increasing order of reduction of alkyl halides. Here they are given the alkyl halide is the one is RCl, the next RBr, the next one is RI. Actually, we know that as we move down the group, like a chlorine, bromine, iodine, the size is bigger in case of the iodine. Then next bromine, then next chlorine. As the size of the halogens increases, the whatever the bond stability is decreases. Then whenever it can be react with these alkyl halide, react with zinc with dilute HCl, you are getting the corresponding alkane is the product. That is, it can be undergo the reduction. In this case, the whatever the RI bond is weak. The stability is less. Therefore, it can be undergo the reduction very easily compared to that of the RBr, then compared to that of the RCl. Therefore, the correct order in this case is RI is greater, then RBr, then RCl. Therefore, option number B. RCl is less, then RBr, then RI. The correct answer is option number B. The next, Which of the following compound is the most stable? The stability of these compounds on the basis of their delocalization of the pi electrons. Here in the case of the option number A, there is a conjugation, okay, between the double bond. It may be stabilized like this, okay. Not complete delocalization, but it has to be stabilized. But in this case, the such type of the effect is not possible. In case of the option number B, option number C, and option number D, the such type of the effect is not there. Therefore, the which compound is the most stable? Therefore, the option number A, due to the resonance stabilization. Resonance stabilization. Due to the resonance stabilization, the option number A is the correct one. The next, the addition of the HBr to the alkene in presence of the peroxide is an example of. Actually, we know that in case of the alkene, the addition of the HBr can take place in two different ways. The one is in presence of the peroxide, the another one is in absence of the peroxide. Here, you have to take the unsymmetrical alkene. Unsymmetrical alkene. In symmetrical alkene, there is no problem, but unsymmetrical alkene. Here, in case of the unsymmetrical alkene, in addition to the HBr, it follows the rule is called as a Marconi-Cos rule. Marconi-Cos rule. Marconi-Cos rule. Then, whenever the unsymmetrical alkene react with the HBr in presence of the peroxide, like benzoyl peroxide or hydrogen peroxide, like that. In this case, it follows the rule is like a anti-Marconi-Cos rule. Anti-Marconi-Cos rule. Anti-Marconi-Cos rule. Okay, anti-Marconi-Cos rule. Here, what is the meaning of the Marconi-Cos and anti-Marconi-Cos rule? The addition of the HBr to the unsymmetrical alkene, it follows the H plus ion. Okay, the partially positive charge ion, like a H plus ion, it adds to the more number of the hydrogen atom across the carbon-carbon double bond, and Br adds to the least number of the hydrogen atom across the carbon-carbon double bond. Here, in HBr, without there is a presence of the peroxide, without presence of the peroxide, it follows the Marconi-Cos rule and it follows the carbocation as an intermediate. Carbocation as an intermediate. But whenever the peroxides are there, it can be form the free radical with the HBr. Free radical with the HBr, then followed by there is a addition reaction can take place. Therefore, the addition of the HBr to the alkene in presence of the peroxide is an example of free radical addition reaction. Therefore, option number C is the correct answer. Here, in absence of the peroxide, it follows the formation of the carbocation as an intermediate, then the addition can take place. And also, I will give one of the example for here in this case for the Marconi-Cos and anti-Marconi-Cos. The first I will give the Marconi-Cos. Unsymmetrical alkene like CH3, CH double bond CH2. The addition of the HBr. It is unsymmetrical alkene. What is the meaning of the unsymmetrical? Here there is the carbon-carbon double bond is there. Here this side only CH2, this side CH3, CH is there. Therefore, it is unsymmetrical. Whenever you can take the ethene, CH2, double bond CH2, it is a symmetrical. Here across the carbon-carbon double bond, here CH2, CH2. Then in this case, in the first case, there is a formation of the product like this. CH3, according to the Marconi-Cos rule, CH3, CHBr, then CH3. Here the H plus adds to the CH2 for the CH2, then Br adds to the CH. You are getting the product is like this. But in case of the anti-Marconi-Cos, you are getting the another type of the product. That is nothing but here prophene react to the HBr in presence of the peroxide. You are getting the bromoprophane is the product. Bromoprophane or 1-bromoprophane is the product. Therefore, correct answer for this one is option number C. The next. The presence of nitro group in a benzene ring. The presence of nitro group in a benzene ring. The benzene ring is there. Presence of the nitro group, NO2 group. Okay, actually electron NO2 is electron withdrawing group. Electron withdrawing group. Electron withdrawing group. Okay, electron withdrawing group. Here the presence of the NO2 group along with the NO2, the some other electron withdrawing groups are CN, then all carbonyl group, then SO3H, sulfonic acid group. These are all electron withdrawing group. Whenever the electron withdrawing groups are present in a benzene ring, it can be activate the ring towards the electrophilic substitution reaction. That is wrong. Not. Then deactivate the ring towards the nucleophilic substitution reaction. Not. Then activate the ring towards the nucleophilic substitution reaction. Activate. That is nothing but the nucleophile, it contains a more, it is an electron rich species. It can be withdraw the electrons, means the whatever the electron density around the benzene ring is less. Therefore, it is easy to, okay, the substitute can take place in a benzene ring. Therefore, the option number 3 is correct. Deactivate the ring towards the electrophilic substitution reaction. Deactivate. It is not activate, deactivate the ring towards the electrophilic substitution reaction. That is also correct answer. Therefore, the option number 3 and 4 are correct. That is option number D. Option number D is the correct for question number 7. The next, we will move on to the next question. The hydrocarbon which can be react with the sodium in liquid ammonia is, okay, the hydrocarbon which can react with sodium in liquid ammonia is the option, the first option. You have to go for the first option, the second option, third option, and option number D. Here one of the condition is that whenever the sodium in liquid ammonia, it can be react with any hydrocarbon, it must contain the free triple bond CH group, like this. Okay, it must contain a triple bond alkane with the free CH group. Okay, therefore here the option in which compound having the triple bond CH, here the option number B, it is a more acidic in nature. Therefore, triple bond CH, it can be easily react with sodium in liquid ammonia. Therefore, the option number B is the correct answer. Here, sodium in liquid ammonia, you are getting the compound is like this: CH3, CH2, C triple bond, C Na, C minus Na plus triple bond. Okay, you are getting the option in which the free CH group is there. Therefore, the option number B is the correct answer for the question number 8. The hydrocarbon which can be react with sodium in liquid ammonia is CH3, CH2C, triple bond CH. The number of primary, secondary, tertiary, and quaternary carbon atom in the molecule respectively. Okay, in the molecule respectively. Here, what is primary? Primary means like free CH3 group. Primary. The secondary means like this, CH2. Okay, then tertiary. It is a tertiary. And quaternary means the carbon atom which contains all the alkyl groups. That is a quaternary. Now you have to identify the which compound in this compound having how many primary, secondary, tertiary of the tertiary, the only one. Here this carbon atom, it doesn't having any CH group, therefore it is a quaternary. Okay. Primary 1, 2, 3. Primary. The primary is 3. Quaternary is 1. Okay. Quaternary is 1. Then tertiary. Tertiary 1. Tertiary also 1. Tertiary. This is tertiary. Then secondary 1, 2, 3, 4. 4 is a secondary. Therefore, the correct answer is on the basis of the order primary. Primary how much? 3. The primary 3. Then secondary 4. Then 1, 1. Therefore, the option number 3, 4, 1 and 1. Option number C is the correct answer for this question. The primary, secondary, tertiary and quaternary carbon atom in this compound. The next question. Butene 1. Butene 1 is same as that of the 1-butene. Okay, 1-butene. 1-butene. 1-butene may be converted to butane by reaction with. That is a butene is nothing but like this. CH3, CH2, CH, double bond CH2, double bond CH2. It is a 1-butene, 1-butene. It has to be converted into the butane. CH3, CH2, CH2, CH3. Okay, in presence of the which reducing agent? The first is zinc with HCl, tin with HCl, then zinc mercury, then palladium with the hydrogen. Here, the alkene can be converted to the alkane in presence of the palladium with the hydrogen. Palladium with the hydrogen. Okay. The active metal in presence of the hydrogen, it can be undergo the reduction. You are getting the answer like a butane is the product. Therefore, the correct answer is palladium with the hydrogen. Okay, palladium with hydrogen. The next question. Homologue pair among the following is. What is the meaning of the homologue pair? Homologue pair. The homologous or homologous series means it has to be written in terms of the general formula, and these are difference between only the CH2 group and the molecular mass is nearly 14. The molecular mass is 14. That is called as a homologous series. Here in case of the option number A, CH3OH, CH3O, here there is a functional group is different, therefore that is not answer. Then second one is also there is a change in the functional group, that is not answer. Then third one is ether, another one is alcohol is there, it is also not there. The option number D, the one is methanol, another one is ethanol. Methanol and ethanol. The homologue pair among the following is the CH3OH, CH3O, CH3. The what is homologue pair? Homologue pair is the whatever the compound, organic compounds having the, you can be written in terms of the general formula. Then whatever the difference between the one compound and the another compound is only the CH2 group. Then it has the molecular mass is nearly, the difference is 14. Here option number A, CH3OH and CH3O, CH3. Here the alcohol is the functional group. Here ether. Therefore it is not a homologous series. Then second one is a methanol and thiol. It is also the not homologous series. Then third one is it is ether, it is alcohol, it is also not. Then the option number D, the one is methanol, the another one is ethanol. The difference between these two is only the CH2 group. Only the CH2 group. Therefore, it can be considered as a homologue pair. Therefore, in this case, the whatever the homologue pair among the following is option number D, that is methanol and ethanol. It can be difference between only the CH2 group. Then the molar mass is nearly 14, and both can be written in terms of the general formula like ROH. And whatever the preparation method is also most probably both methods both compounds can be prepared by the same method. Therefore, the correct answer is option number D. The next question number 12. IUPAC name of the compound is. IUPAC name of the compound is. Here in this compound, one double bond is there. Therefore, the double bond is the like a functional group for in this compound, and that double bond must get the least number. Least number. Whenever you can give the number for the carbon atom, double bond must get the least number. Therefore, I will give the number for this compound 1, 2, 3, 4, then 5. Otherwise, I will give the number like this 1, 2, 3, 4 or 1, 2, 3, 4. But whenever I can give the number for this carbon is number 1, I must get the only the 4 carbon atom in a root 1. But according to the rule itself, it must contain the maximum number of the carbon atom. Therefore, the correct order is 1, 2, 3, 4, 5. Now, whatever the carbon number 3 has one CH3 group, then 4 has one CH3 group. Now, third carbon and fourth carbon having the CH3 group, therefore 3,4 dimethyl. The double bond it can be presented, okay, 1, 2, then pent 2-ene. Therefore, the correct answer is 3,4 dimethyl pent 2-ene. 3,4 dimethyl pent 2-ene is the correct answer for this question. Okay, clear no? I will give the number 1, 2, 3, 4, 5. Therefore, the root word is pent. It has the double bond in the second position. Therefore, 2-ene, pent 2-ene. Then the remaining is a substituent, the carbon number 3 and 4. Therefore, 3,4 dimethyl pent 2-ene is the correct answer for this question. The next. The type of the carbon intermediate obtained when the carbon-bromine bond cleaves in the following molecule is. Okay, the molecule is like this. Whatever the compound it can be obtained during the cleavage of this compound. Here the option is carbocation, carboanion, free radical, and the carbene is there. Actually it is like a carbon atom is, it contains a CBr group. It can be formed the stable carbocation. Whenever it can be undergo the cleavage of the CBr bond, the bromine is more electronegative. Bromine is electronegative. It can be take the electron towards itself, whatever the bonding electron. Therefore, it can be formed the carbocation is the intermediate. Carbocation is the intermediate. Actually, it cleaves. It gives the compound is like this. CH3, then C, CH3, CH3, then here positive charge plus Br minus. You are getting the intermediate is like a carbocation. Okay, do you know that in case of the carbocation, the tertiary carbocation is more stable, then secondary, then primary, The tertiary carbocation is more stable, then secondary, then primary. The next question, question number 14. Among the following most stable intermediate is, okay, most stable intermediate is, there are 4 intermediates there. The in which one is the more stable? Here in which the most stable intermediate is the option number A. Why it is more stable? This is mainly because of the benzene ring with CH2 group, CH2 plus, that is a phenyl. The phenyl group with CH2 plus, that is called as a benzyl carbocation. Benzyl carbocation. The always the benzyl carbocation is a more stable compared to that of the any other carbocation. This is mainly because of phenyl group. This is mainly because of the whatever the carbocation obtained, it can be stabilized by the resonance. It can be stabilized by the resonance effect. Resonance. Therefore, this carbocation is a more stable among the following intermediate. Option number A is the correct answer. The next question. The hybridization of the carbon in CH3. Actually, the complete structure of this compound is like this: CH3, C, triple bond, C, then CH, CH3, CH, double bond CH2. Double bond CH2. Here, carbon-carbon triple bond is there. That is nothing but the sp hybridization. Then carbon-carbon double bond is there. It is sp2 hybridization. Then CH3 group is there. It is sp3 hybridization. You have to observe the hybridization like sp3, sp, sp2. Therefore, sp, sp2, sp3 is the correct answer. The hybridization of the carbon atoms in this compound is sp, sp2, sp3. The next question. Among the following molecules, the plus I effect of the methane is not present in. Among the following molecules, the plus I effect of the methyl is not present in. Here, the first option in which the benzene ring contain CH3 group. Okay, CH3 group. The second one, CH2 double bond, then CH3 group is there. In the option number C, the cyclohexane, it contains CH3 group. CH3 group. The last one, CH3 C double bond O. It is like aldehyde group. Okay. The in which there is some conjugations like double bond is there. Here benzene ring is there. Here the carbonyl group is there. But in the option number C, there is no conjugation. There is no effect. Okay. Then the whatever the CH3 group is electron donating group, but it doesn't shows the plus I effect. Okay. Among the following molecules, the plus I effect of the methyl is not present in the cyclohexane with the CH3 group. Okay. Therefore, the correct answer is option number C. There is no double bond. Okay. There is no double bond along with the conjugation. Therefore, there is no change in their polarity. Therefore, correct answer is option number C. Then 17. The principal factor to separate two solids by fractional crystallization is. Okay. The which principle it can be take place in case of the fractional crystallization. Okay. I will tell you about the what is crystallization. The crystallization means you have to separate out the compound with the impurity. First, you have to dissolve with a particular solvent. Then you have to boil it slightly boil it. Then you can be filtrate. Then whatever the filter paper it contains, the impurity can be present. Then you have to separate out the pure substance. It can be undergo the crystallization. This is mainly depends upon their solubilities. The principal factor to separate two solids by fractional crystallization is it depends upon their solubilities. Therefore, the correct answer is the solubilities. It doesn't depend upon their densities or melting point or boiling point. It depends upon their solubilities. The boiling point it can be depends upon like a distillation. Okay, distillation it depends upon their boiling point, but here the solubilities it depends upon their fractional crystallization. The next question, question number 18. The type of isomerism that is not found in alkene is metamerism, chain isomerism, geometrical isomerism, and position isomerism. Do you know that the alkene, it contains carbon-carbon double bond, carbon-carbon double bond can be present. The metamerism, chain isomerism, it must having the chain isomerism. Like in that chain itself, for example, CH2, double bond CH, single bond CH2, CH3. It is one butene. You have to write the two butene, CH double bond CH, single bond CH3 and CH3. It is example for the chain isomerism. In the chain, there is a chain. Okay. Then geometrical isomerism. It is also example for the chain as well as the position also. Position isomerism. Here, like position of the carbon-carbon double bond is changed. Therefore, position isomerism. The chain means there is some alkyl chain is there, like okay, CH3, C double bond CH2. Okay, then CH3, CH3. Then another compound it contains like CH2 double bond CH3. Okay, then CH3. Okay, the such type of the example in case of chain isomerism. Then geometrical isomerism. Geometrical isomerism, do you know that? Like a cis and trans isomerism. Cis and trans. If it is the identical groups are present on the same side, then it is a cis. It is example for the cis isomerism. Then trans means the whatever the identical groups are there, it can be present in the opposite side. That is a trans example is C double bond C, H, then H, CH3, CH3. It is a trans isomer. Trans isomer, cis and trans isomer. Okay. Therefore, the position isomerism is possible, geometrical isomerism is possible, and chain isomerism is possible. But it doesn't having the metamerism. What is the meaning of the metamerism? The metamerism means that actually in case of the metamerism, okay, metamerism, the metamerism here in case of the metamerism, it can be present in case of ethers. Here C2H5 O C2H5. Okay, it is isomerism with the another compound is like CH3 O C3H7. In case of the ethers and ketones also, you have to observe the metamerism. Here the functional group is there. On either side of the functional group, okay, here the alkyl group is like C2H5, C2H5. But in this case, the one side the alkyl group is CH3, the another side C3H7. There is a methyl and profile. The on either side of the functional group, there is a different alkyl groups are there. Different alkyl groups are there. Then it is called as a metamerism. The such type of the isomerism is not possible in case of the alkene. Therefore, the correct answer is the type of isomerism that is not found in alkene is metamerism. The next question. Urea or thiourea exhibit metamerism, tautomerism, functional isomerism, and geometrical isomerism. Here the correct answer for urea and thiourea. Urea and thiourea. What is the difference? The urea. Here NH2, C double bond O, NH2. It is urea. Thiourea means the only the change C double bond O, it can be replaced by C double bond S, then NH2, then NH2. It is a thiourea. In case of the urea and thiourea, it can be exhibit the tautomerism. Now, what is the meaning of the tautomerism? The tautomerism means the whatever the lone pair of electrons which can be present on the nitrogen, it can be moved like this. Then here. Therefore, it has the tautomerism. The structure of the tautomerism is like this: NH2, C, OH, O minus, or it becomes OH, then double bond NH. Double bond NH. Here, in case of the thiourea also, it can be exhibit the isomerism is like this: NH2. Okay, in any side, in another side also, you have to get the same type of the structure. The correct answer is It is a tautomerism. It shows that like a tautomerism. The correct answer is a tautomerism. Urea or thiourea exhibit a tautomerism. The next. Identify the chiral molecule among the following. The isopropyl alcohol, then 2-pentanol, 1-bromo, 3-butene, then isobutyl alcohol. You have to write the structure, then you have to identify the which compound having the chiral. Here isopropyl alcohol means like CH3, CH, CH3, OH. It is isopropyl alcohol. Actually the isopropyl alcohol doesn't having the chiral carbon because what is the meaning of the chiral carbon? The chiral carbon means it must having the 4 different groups or atoms around the carbon atom, But here in this case, in isopropyl alcohol, it must having the 2 same group like CH3 groups are there. Therefore, it doesn't having the chiral carbon. The next 2-pentanol. Okay, you have to write the structure of the 2-pentanol. Then you have to identify whether it having the chiral carbon or not. Okay, 2-pentanol. You have to write the structure 2-pentanol, CH3, C, H, OH, then CH2, CH2, CH3. Therefore, 2-pentanol, the structure of the 2-pentanol. Here the OH group, here H, here CH3, then C3H7 group is there. It has the chiral carbon. Okay, chiral carbon for 2-pentanol. 2-pentanol having the chiral carbon. Then you have to write the other structure also. For example, 1-bromo, 3-butene, 1-bromo, 3-butene, 1-bromo, CBr. Okay, 1-bromo, 3-butene. CH2, CH2, okay, carbon atom, then 3-butene, 1, 2, 3, 3-butene, CH2, CH. Okay, it doesn't having the chiral carbon, therefore that is also wrong. Then isobutyl alcohol having, it doesn't having the chiral carbon. Okay, isobutyl alcohol doesn't having the chiral carbon. Therefore, the correct answer is the 2-pentanol is the correct answer. 2-pentanol is the correct answer. The next question is, which of the following behave as both nucleophile as a electrophile? Here CH3OH, CH2 double bond, CH single bond, CH3, CH3NH2. Here the correct answer, the nucleophile as well as the electrophile, it can be act as a this one, CH3, C triple bond N. Okay. Here the compound name is methyl cyanide. Methyl cyanide. Okay, methyl cyanide. Methyl cyanide. The IUPAC name of this compound is, you must know the IUPAC name of this compound, that is ethane nitrile. Ethane nitrile. Why it can act as a both electrophile and nucleophile? That is nothing but the carbon here, it has the negative charge. Whenever it can be cleaves, the carbon it can having the positive charge, CH3, CH3 plus and Cn minus negative charge. Therefore, it can be act as both electrophile as well as the nucleophile. Electrophile as well as the nucleophile. Therefore, the correct answer is the option number A. The next question. Which of the following is correct regarding minus I effect of the substituent? Minus I effect. Okay, the plus I effect as well as the minus I effect. Here we will move on to the electronegativity. Here the fluorine is more electronegative. The next oxygen, the next nitrogen. Next nitrogen. Here the minus I effect is nothing but it has to withdraw the electrons towards itself. Therefore, the more electronegative element, it can be ability to attract the electron towards itself. The fluorine having the more electronegative element, therefore it has the more capacity to withdraw the electrons. Therefore, in this option, the one is Nr2 is there, OR is there, and F minus is there. They here F minus, then OR minus, then OR, then next Nr2. Okay, Nr2, the in which the F minus having the more ability to withdraw the electrons. Therefore, the correct answer is option number A. That is Nr2 is less than OR and F. You have to tell the answer on the basis of their electronegativity. Electronegativity. Here the question is very clear. The minus I effect. Minus I effect. Whenever they will ask the plus I effect, then the order is reversed. Plus I effect, the order is reversed. The Nr2 is greater than OR. Then next F minus, plus I effect. Plus I effect and minus I effect. The plus I effect you have to observe when the electron donating groups, and minus I effect you have to observe whenever the electron withdrawing groups are there. Question number 22. The next. The reaction which forms 2,2 dibromopropane is 2,2 dibromopropane is. Okay, we'll move on to the option. The option number A, that is profine. Profine. The structure of the profine is CH3, C triple bond CH. Profine. React with HBr. There are two molecules of HBr. Okay, I will take the first one HBr. You are getting the product is according to the Markovnikov's rule. Here H having the partially positive charge, then Br having the partially negative charge, then H plus it adds to the here this carbon atom, Br minus here. Therefore, you are getting the product is CH3, C, Br, double bond, CH2. Again, it adds with the one more HBr. One more HBr. The same principle. According to the Markovnikov's rule, Br, then here H, you are getting the product is CH3, C, Br, then Br, then CH3. CH3. Okay, CH3. Therefore, the reaction which forms 2,2 dibromopropane. Therefore, the 2,2 dibromopropane. This is the 2,2 dibromopropane. Therefore, the option number A is the correct. Like that, you can go for the option number B, option number C, and option number D. You are not getting here option number D. It is a HBr. Okay, HBr. Then you are not getting the 2,2 dibromopropane. Therefore, the option number A is the correct one. The next. Of the 5 isomeric hexanes, the isomer which gives 2 monochlorinated compound is 2 monochlorinated compound. The 2 monochlorinated compound means it must having the only one chlorine atom, but you are getting the 2 monochlorinated. That is a 2 different product you have to get. But in case of the option number A, N-hexane, you are getting the not 2 monochlorinated. You are getting the number totally. Okay, I will go for the option number A. N-hexane means the structure is like this: CH3, CH2, CH2, then CH2, CH2, CH3. It is a N-hexane. Whenever you can go for the chlorination, you are getting the product is one. It can be substituted here, the one of the product. The second one is here. Then third one is this one. Okay. Then this product is same as that of the third one. Second one, then first one. Here in this case, you are getting the 3 compound, 3 monochlorinated compound. Therefore, the option number A is not possible. Then you can go for the option number B, 2,3-dimethyl butane. You have to write the structure. Whenever any organic compound is there, how to write the structure of the compound? Like 2,3-dimethyl butane. First, you have to write the root word like a butane, C, 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 C. Butane. Total number of the carbon atom is 4. Therefore, butane. Then the second carbon and the third carbon having the CH3 group. Okay. Now you have to the balance with the hydrogen atom. The carbon is a tetravalency. Therefore, CH3, then CH, CH, then CH3. This is the compound is 2,3-dimethyl butane. 2,3-dimethyl butane. Whenever it can be undergo the chlorination, Cl2, you are getting the product is the one is it has to be substituted here Cl. Okay, the one of the product. This product is same as that of the here. Okay. Well, like that, it has to be substituted for this CH3 and this CH3. Okay. Here also you are getting the product is remain the same. One. Okay. Whenever the chlorine can be substituted to the this C carbon atom or this one or this one or this one, you are getting the product is remain the same. That is the product is remain the same, unique product. Then another one option is whenever the chlorine it can be substituted to this carbon atom or this. Okay, this one or this one. Here also you are getting the product is remain the same. Product number 2, it is also product number 2. Therefore, the correct option of the 5 isomeric hexanes, the isomer which gives 2 monochlorinated compound is 2,3-dimethyl butane. 2,3-dimethyl butane. Like that, you have to go for the 2,2-dimethyl butane and 3-methyl pentane. You are not getting the only 2 monochlorinated. You are getting the more than 2 monochlorinated compound you may get. But in case of the 2,3-dimethyl butane, you are getting the only 2 monochlorinated compound. Therefore, the option number B is the correct answer. The next. In the following sequence of the reaction, compound B is. What is the compound B? Here in this reaction, you may know that actually the alkene react with ozone followed by hydrolysis. This reaction is called ozonolysis. Okay, ozonolysis. Do you know that whenever the ozone it can be react with the alkene, you are getting the ozonoid. Further, it can be undergo the hydrolysis, you are getting the corresponding aldehydes or ketones. The mixture of the aldehydes or ketones. Here in this reaction, 2-butene react with the ozone. The first 2-butene, it can be react with the ozone, CH3, CH, double bond, CH, single bond CH3, react with ozone like a O3. You are getting the product is like this, ozonoid, CH3, CH, O, CH, O, and CH3. Okay. Further, it can be undergo the, this is called as a ozonoid. Further, it can be undergo the hydrolysis in presence of the zinc and water. It can be undergo the hydrolysis is like this. Okay. You are getting the corresponding acetaldehyde. You are getting the product is acetaldehyde. CHO. Therefore, option number B is CH3CHO. That is acetaldehyde. Okay. The next question number 26. Heterolytic fission forms. Here, in case of the fission, there are 2 types of the fission. The one is a homolytic, another one is a heterolytic. Homo, do you know that? Homo means equivalent. Here, the equivalent, whenever the bond, it can be undergo the break, each species get the single electron. Adana homolytic anta karitivi. The another one is heterolytic. Here the question is heterolytic fission forms. Here cations, anions, free radical, both cations and anions. Then actually you are getting the both cations and anions. Okay, I will give one of the example, the heterolytic fission. I will take the HBr. Okay, in case of the heterolytic fission, the bond it can be undergo the breaking. The whatever the electrons present in a bond, it move towards the more electronegative element. Okay, it move towards the more electronegative element. Okay, then it can be forms H plus ion plus Br minus. H plus ion and Br minus. This is the cation and this is the anion. Therefore, the correct answer is both cations and anions. The next. But in case of the homolytic fission, okay, I will tell you about the homolytic fission. For example, I will take one of the example like Br with another Br, like a bromine molecule. It can be undergo the fission like this. Okay, the whatever the electrons which can be present in a bond, it can be undergo the fission. You are getting the Br dot, 2Br dot. It is nothing but the free radical. Okay, in case of the homolytic fission, you are getting the free radical. In case of the heterolytic fission, you are getting the cations and anions. The next question. The most suitable method for separation of the 1:1 mixture of the ortho and para nitrophenol. Okay, ortho and para nitro. Okay, I will write the structure of ortho nitrophenol, phenol, the ortho nitro. Then another one is para nitrophenol. Okay. In case of the orthonitrophenol, you may observe that the one of the bond which can be exist. Okay, that is intramolecular hydrogen bonding. Intramolecular hydrogen bonding. Hydrogen bonding. Intramolecular hydrogen bonding. But in case of paranitrophenol, there is an absence of the intramolecular hydrogen bonding. Absence of a intramolecular hydrogen bonding. Whenever the intramolecular hydrogen bonding is there, it can be boiled at a higher temperature compared to that the compound which doesn't having the intramolecular hydrogen bonding. Therefore, whenever there is a change in their boiling point, you may go for the distillation, like a steam distillation. Okay, steam distillation. Therefore, the correct answer, the most suitable method for the separation of the 1:1 mixture of the ortho and paranitrophenol is distillation. The correct answer is distillation. The next. In the reaction, the what is B? Okay, what is B? The reaction is like this. The benzene react with CH3Cl in presence of the anhydrous aluminum chloride followed by KMNO4. Okay, here the benzene, you can take the benzene. Benzene, then CH3Cl with the anhydrous aluminum chloride. Aluminum chloride. You are getting the product is like a toluene. The first you are getting the toluene. You are getting the toluene. Then the toluene, it can be reacted with KMNO4. KMNO4. Here CH3 group can be undergo the oxidation. You are getting the product is benzoic acid. Benzoic acid. Here KMNO4 can act as an oxidizing agent. Therefore, CH3 group can be converted to the COOH. Therefore, the correct answer for this one is benzoic acid. Initially, the benzene reacts with CH3Cl in presence of the anhydrous aluminum chloride. It is a Friedel-Crafts alkylation reaction. You are getting the toluene is the product. Then followed by KMNO4. Then it can be undergo the oxidation. You are getting the benzoic acid is the product. The correct answer is benzoic acid. The next question. Match the following the reactants in column 1 with the corresponding reaction products in column 2. Here benzene with chlorine, then benzene with CH3Cl in presence of the aluminum chloride. It is aluminum chloride, AlCl3. It is also aluminum chloride. Here KMnO4 with the NaOH. Here benzene with chlorine in presence of the aluminum chloride, you are getting the chlorobenzene is the product. Okay, chlorobenzene is the product. For A, fourth is the answer. Benzene in presence of the CH3Cl, you know that it is a Friedel-Crafts alkylation reaction. You are getting the toluene is the product. For B3, A4, then C, benzene with CH3Cl, you are getting the product is methyl phenyl ketone, benzene with the CH3Cl. Okay, you are getting the product is like this, the benzene with the CH3COCl, you are getting the product is COCH3. Therefore, the correct answer is this one. Then toluene, it can be undergo the oxidation in presence of the KMnO4. You are getting the benzoic acid is the answer. Therefore, the correct is option number A. Option number A is the correct answer. That is for A, it is 4, B 3, C 2, D 1. The next question. Among the following, the one that is not a meta-directing group, okay, do you know that the one is meta-directing, another one is ortho and para-directing. Here the meta-directing means electron withdrawing groups are there. Electron withdrawing groups are there. It is a meta-directing, electron withdrawing. For example, in case of the CN, NO2 or carbonyl group, then SO3H. These are electron withdrawing group. Therefore, it is a meta-directing. Okay, I will give one of the example. For example, the benzene ring is there. It is NO2. I will go for the reaction with the CH3Cl in presence of the aluminum chloride, anhydrous aluminum chloride. Here, I will get the product is a meta product. NO2, then CH3, meta product. Okay, it is a stable. But whenever electron donating groups are there, for example, phenol, okay, phenol, it can be react with CH3Cl, anhydrous aluminum chloride. I will get there are two products. The one is paramethyl phenol, another one is orthomethyl phenol. Okay, ortho and para product. The in which the para product is the major one. Here the question is, among the following, the one that is not a meta-directing group is, therefore, the OH is not a meta-directing, then CN, NO2, SO3H all are meta-directing group, but OH is not a meta-directing group. Okay, like that, I will end with this session. Okay, thank you one and all.